Namaskar and Manakam. So this is a nice opportunity, and I would like to thank the Alpha webinar for having given me opportunity to discuss with you on the very burning issue, the spread and the effect of novel coronavirus and how it is may likely to impact on our industry. So this is a subject. I'm not an expert on either biology or virology or microbiology, etc. All these things comes because of some experience that I gained and also by self-reading. Now, before, if we jump into the first, into the corona, it will be very confusing. So I thought that I should give a fundamental idea of virology first. Next slide, please. So what is a virus? Virus in Greek means poisons, and it was coined by Edward Jenner in 1798. So it is about 250 years almost that the virus is known to us. It's not something new. Yeah. So if the virus is a poison, then really it's a matter of great question, valid question, that can we poison a poison? How can we kill the poison or impact a toxicity on it? They are obligatory intercellular parasites. That means in order to sustain their life, they need some host. We in tannery know such parasites, for example, warble fly, for example, ticks, which thrives on the living cow. But warble fly or the ticks also are dead when the cows are slaughtered because they are not getting the live host. In absence of live host, they also die. They are very smallest infectious agent having a very simple structure. They have just only one nucleic acid, either a DNA or RNA, not both. And in fact, the virus is not a true cell because the cellular components, what are required, some of the cellular components are missing from them. They are, for example, ribosome. They are, for example, mitochondria, Golgi apparatus, then endoplasmic reticulum, cell walls, etc. These are not there in a virus. So frankly speaking, we cannot call them as a true cell. Next slide, please. Next. How small are they? A bacterium, for example, has a size range in terms of diameter about 2 to 2.0, 0.2 to 2.0 micrometer. 1 micrometer is 1/1,000,000th part of a meter. Vis-a-vis, a virus is only 20 to 200 nanometer. 1 nanometer is 1/1,000,000th of a meter. So, in the size of if you compare the size of a virus as compared to size of a bacterium, then bacterium is 1,000 times more bigger than that of a virus. So it is so tiny. Now, if we assume, it is not possible theoretically or practically, but if we assume just a mental experiment, mental thought, that if we are able to magnify it by 200,000 times, that is 2 lakhs times, then bacterium will look like our triple helix auditorium. And in relation to this triple helix auditorium of a bacteria, the virus will occupy just the podium, somewhere in the auditorium. So that's the ratio of the size of bacteria as compared to the virus. Virus is also able to infect bacteria. Bacteria infect us, but virus infects bacteria as well. Next slide. Now, virus needs a certain steps, and these steps are followed one after another. The first need of the virus is that they need a living host cell. This is the first and foremost requirement in order to reproduce, because they are living, so they have to reproduce. In order to reproduce, they need a living host cell. Living host cell, I am again repeating, this is a very important word, that they needs a living host cell. And the first thing what they would do, they would attach themselves to the living host cell first. So there should be a contamination, a kind of attachment. And once it is attached, then the thing will penetrate inside, will go inside, will sit inside. And then third step is a uncoating, that is opening, the cracking the cell wall and injecting its own nucleic acid, that is RNA or DNA, into the host cell. Why do they do that? The first reason is they do, as I have said, they don't have all the components that requires a cell. They don't have tRNA, they don't have a ribosome because they are too small to accommodate a ribosome. You cannot have some apple whose seeds are bigger than the apple. So they don't have it. They have to procure it. And they use the host cells apparatus, host cells tools, or the machinery of the host cell to do their job. In terms of canary language, I can call it as a job working that they have to do. Then they uses the machinery of the living host cell to reproduce themselves by asexual reproduction. And thereafter, these parts are assembled together within the host cell, and then they leave the host cell for as a new grown, as a nascent virus to attack some other places. That is how the cycle goes. Next slide, please. So what happens to the host cell? The pathogenic effect of the host cell can be of two types. The host cell can tolerate as such without any change, or there can be a lysis, that is the destruction of the host cell. And one of the reasons for this, that the cell variety or the cell type changes, and the worst possible case, if this changes for the controlling cells, then the cell growth can be uncontrolled. Yes, you are correct. I am talking about development of the carcinoma. Carcinoma can be developed by the injection of a virus, special type of virus, which can do the destruction or lysis of a cell and causing an uncontrolled growth thereby. And these genes that this virus contains are called oncogene, from which the word oncology or the oncologist has been coined. Usually they prefer, previous slide please. Usually they prefer specific host cell like bacterium, like plant, like animal, or like human. Mind it, there is no mention of fungus here. The fungus is not their preferred host cell. Bacteria, plant, animal, or human. Next slide. For this virus, this is called as a life cycle of a virus. You can see on the left-hand side, there is a lag phase, the infection began. And almost this is a parallel to the x-axis. This is plotted as a number of virus or number of cells as a function of time. So between 1 and 1.5 hours, as indicated in the graph, there is a lag phase. That is, rate of growth is almost constant. There is no change in the rate of growth. And thereafter, there is a sudden jump, exponential phase. That is, they grow exponentially, 2, 2 to 4, 4 to 8, 8 to 16 in a GP series, geometric progression series. And where, obviously, the dn by dt, if the n is the number of cells and t is the time, dn by dt is very positive here. The gradient is very sharp. Then it comes to a stalemate, a plateau, which is called a stationary phase. That means at this particular point, we can see a light from in the tunnel. That is, the death rate is equaling to growth rate. And thereafter it follows a growth rate, that is the death rate, that is dn by dt is equal to negative. And the projection of the lag phase to the death phase on the time axis is the period of the lifespan of the bacteria of the virus. The lifespan varies from one virus to the another virus. Next slide, please. Next slide. So entire section of the time axis is the span of a lifespan of a virus, and it depends from species to species. For example, common influenza, it takes about 1 week. That means 7 days. For chicken pox, it is about 3 weeks or 21 days. And for COVID-19, it is about 2 weeks or 14 days. That is this lifespan, that is the time they will remain in the host cell and then they will escape. Next slide. I am again repeating, there is no direct medicine to kill the virus. Up till now, there is no direct medicine to kill the virus. Because I have already said virus has been named as a poison, and probably we cannot poison a poison. So there is no direct medicine to kill the virus. What the physicians do, they only do the symptomatic treatment to give some relief. For example, if you have influenza, if you are suffering from high fever, they will say, go and take a paracetamol. If there is a diarrhea, they will say, oh, no, you go for anti-diarrhea or something. They give some kind of relief to the patient, but whether you take it or not, it will remain for 1 week. So there is a famous joke. It says that if you give the drug, the flu will disappear in 1 week, and if you don't give the drug, it will remain for 7 days. That's the difference in number, but the period is the same. And again, I am trying to see this, to tell this, that virus requires a live host cell to thrive on it. Without the live host cell, the virus is as good as dead. The lifespan of CoV2 is the scientific name of the COVID-19 virus, on the material used for household scores are understandable and justifiable. For example, what is the lifespan in the wood which is used as a table? What is the lifespan which is used for the lifespan of CoV2 on the cooking materials, cooking accessories? What is the lifetime of the CoV2 on steel? What is the lifespan of the CoV2 on copper? What is the lifespan of the CoV2 on the flooring material or a concrete? These are all important because it is important to know that how long they are surviving alone and how we can get contaminated. But I am just asking you and telling you that even a wet salted raw hydrogen skin doesn't have a live host cell, because the skin were flayed off from the animal died, and so skin cannot have a living host cell where they can thrive, the corona, novel corona, COVID, or any other virus. Not bacteria, I'm talking about virus. And if the leather, the raw hydrogen skin, wet salted raw hydrogen skin doesn't have the accommodation for living host cell, how come a finished leather can have a living host cell? So the probability of having living host cell in a finished leather is 0. So that gives me a very peculiar kind of a mixed feeling, that why on the good earth someone would investigate the lifespan of CoV2 in footwear or leather goods, when leaving many other frequently used material at bay. How many times we handle the footwear? How many times we handle the leather goods? Touch with our hands or other things. And there are so many other things which we handle more frequently. Their lifetime has not been investigated. Why are they investigating on leather and the leather footwear and the leather goods is a matter of big surprise to me. Next slide. Now coming to CoV2. You can see on the left hand side there's a picture, a photograph of the picture taken in the in a very high power electron microscope, same of a CoV2. You can see the spikes. The spikes are the spatial protein with a particular domain structure. And there are 4 kinds of proteins which makes the cell wall. E type, E protein, S protein, M protein, and H protein. This is this area which is marked over here that exactly gets cracked and the RNA comes out from the COVID-19 into the host cell when they penetrate into the host cell. Now, as I have said that there are certain steps. The first one is the attachment. Now here is an interesting thing you can see in the picture. The light blue is light blue shaded portion is the cell, living host cell, right? And in the cell membrane, outer cell membrane, and there is an inner cell membrane. In the outer cell membrane, when you see a green portion, that is actually called as a RBD. And you can see on the top of that the spikes and the surface, upper surface of the RBD are just complementary to each other. So these spikes of the corona can fit into the RBD as a male plug, fits into the socket, female socket. So they fits into it. Once they fit into it so closely that there are a lot of secondary valence forces that operates in them and makes this complex stable. And then this RBD drags this corona inside the hole by puncturing the cell wall. The first is the attachment, then is the penetration. Penetration can only happen if the RBD binds with the corona in its spikes. Spikes is actually a protein, is the S protein, having a special domain structure. Next slide, please. Now, if you look at this, this is the secondary structure of the spike protein of CoV2, and you can see there are 3 distinct polypeptide chain of small molecular weight. There are hardly 200 to 300 amino acid sequence in every polypeptide chain. They are not very big, they are not very large because the virus itself is small, so it cannot be very large also. So they are very small polypeptide chains, oligopeptide chains, you can say, about 4 or 5, 3 or 4 amino acid polypeptide chains of having 200 or 100 or 200 amino acid residues at the sequence and the per cell, per polypeptide chain. Next slide. Here is the entire story. In the left hand side, just follow the arrows from the left hand side, you see that the receptor binding domain, RBD, receptor binding domain is fixing on the spike of the virus, corona CoV2 virus, and they are bringing this inside. It acts as now as a transport, as a lorry, it brings up inside, and then RBD becomes inverted upside down like a umbrella in a rainstorm. And at the same time, when this happens, at the same time there is a lysis, the opening of the cell wall. The cell wall is not now spherical. You can see that some part is broken. And this is a proteolysis that takes place, and the RNA is going to come out. Then the RNA goes for translation process to produce the protein. This protein are used as a cell wall. In this one, you can see the cell wall is being developed. RNA is replicated to produce another RNA which forms into the daughter cell. The protein is synthesized by this RNA in the translation process using the machinery of the host cell, like in the Golgi apparatus and the endoplasmic reticulum, where we can see that they are using in this a little bit of violet colors, ribosomes and others to produce the protein. And then they assemble these things. And then when this is totally formed, the daughter cell is formed, the daughter cell now escape from the cell into the ambience, into the air. Next slide, please. Now here come an interesting story. You can see the left-hand side correspondingly the right-hand picture. You see, I have intentionally drawn this one, RBD, as something like a blue color. You can see that they are complementary binding with the spikes of the COVID COV2, and then they are allowing it to penetrate. Look at the right-hand side. Right-hand side, you see the receptor binding domain is just a complementary, is just some concave to the same extent as that of a sphere of the spike. So there is a lock and key kind of a response, and this response makes release a large amount of stability, and this stability is helpful for penetration so that they don't fall apart. When they come in, this receptor RBD takes the coronavirus as a whole and penetrates inside the cell. Next slide. Now, if by some means I can change the structure or the gateway, that is the RBD, in a manner that it is no more in the original fashion, then I can create a kind of a no entry gate. And in that case, the option for the spikes to touch the gate is very small. So it is not very stable, complex, and therefore it is not going to penetrate because the entry gate is now having a no entry sign. So therefore this penetration is lost. And if this penetration is lost, then therefore they cannot further proceed for the next growth cycle. This is the pattern how the vaccines also can be developed for such type of mutated virus. And I am happy to tell you that one of my students are working on it. He has been very advanced at, and I wish that by the time of October or November, he'll be able to do the experiments on the human. Next slide, please. Now, how can you alter the protein structure? Protein structures comes from the DNA. And what we are going to, what our target area is the target area of receptor binding domain. That has been identified, the genome sequence has been identified from 460 to 560. You can see the lines, blue lines. You cannot read the ATGC because this is very small. These are covering the same column with the same color. That means very similarity from one gene to another gene. Now look at the B, small b portion here. You see, human, first line is the human SARS-CoV-2, then bat, then pangolin, then human SARS-CoV, and then bat
it's 5 o'clock.
And then bat SARS-CoV related. And then you can see there also there are similarity, overlapping zones between different kind of the mutants, but there is some kind of a similarity in this area. That means what? What we thought first, that see, COVID was already there. It is not that it is a new one. COVID was there for 400 or 200 or 300 years. Every pets are used to have a COVID, the coronavirus vaccination every year, once in every year. But that corona was not able to penetrate through the human cell. Human cell was not their choice. But it is said that the coronavirus was spread from the animal shop of the Wuhan city, of the Wuhan state of the China, where it came first from the bat, then it is percolated to pangolin, and from there it is human. So it is necessary to see that this kind of transfer from one animal to another animal must take a minimum lead time of 6 months. So it is necessary to see whether there was a further mutation, that is further alteration of the sequence of the gene. But here you can see that from the gene structure that the sequence of the genes, the color indicates that they remains almost the same. So there was not much of mutation that has taken place. That is a good and a blessings that we can do it. Now what we should do, when we know in the last from 460 to 500 sequence, you can see that this is the domain of the receptor binding domain. And if we can do either by cloning or by recombinant DNA, it can change this one by a kind of a what we call as a something like a plastic surgery, put some other sequences and alter the folding, we can develop that kind of a no entry gate for the COVID. And this is what my student is doing. Next slide, please. You have seen in the earlier slides that left hand side, one COV2 is entering. Right hand side, you have seen one COV2 is escaping. If one comes in and one goes out, then how come we have such kind of exponential growth? This could be a mind. But you can see there's exponential growth means from 1 to 2, then in the second generation 2 to 4, the third generation 4 to 8, 2 to the power n. This is where the way it grows. This reminds me to tell you a funny story. There was one monk who went to a king, and the king wanted to give him some kind of award for his good practices and others preaching his subjects. So he said that you ask anything, I will give it to you. He said that you bring me a chessboard. The chessboard was given to him. He said that put one mango on one box and one block, and next day you will put 2, next day you will put 4, like that. When the 64 is filled up, I will take the whole lot. I have calculated when 64 comes out, how many mangoes it would be. And it comes to a very funny figure, a very astonishing figure. 2 to the power 63 means 9 million trillion. So when you see, this is the case with the infection also. When you see there is a lag phase, then there is an exponential phase when there is a massive contamination through kind of a social contacts and others, and therefore the number of infected infected patients in corona increased in geometric series, giving at least an astonishing figure. That's the exponential growth means. In the lag phase, when dN by dt is positive, and it is a very sharp increase in the slope, the gradient is very sharp. Next slide, please. Next slide. Yeah. Now let us discuss about the drug versus vaccine. What is a drug and what is a vaccine? Drug directly kills the bacteria or the fungi. For example, we use rifampicin, an antibiotic called rifampicin, for eliminating the tuberculosis, that is killing the bacillus tuberculosis. We give nitrofurantoin, an antibiotic for urinary tract infection, UTI. It is actually a benign bacteria, Escherichia coli. They are targeted for them. They eliminate Escherichia coli. And when we are unable to identify the bacteria, or when their patient comes and patients are in a hurry, the patient party is in a hurry, doctor, without going for investigation, what is it due to, by seeing the symptom, they give a broad spectrum antibiotic, which kills irrespective of any kind of bacteria, whether pathogenic, non-pathogenic, whether hostile or friendly, they kill all together. And as a result of this, I have just to mention here that it is not that all bacteria are harmful. Pathogenic bacteria accounts for only 2 to 3%. 98 to 97 to 98% bacteria are very friendly and they are required. If you want to stay in a bacteria-free world, you will not survive. Our gastrointestinal tract contains a huge number of flora and fauna. Therefore, when this kind of broad spectrum drugs are introduced, you will suffer from indigestion problem because they will kill all the flora and fauna in the GI tract, irrespective of whether they are pathogenic or they are friendly, whether they are hostile or they are benign. We require them. And what is the route? What do you do then? You ask them, you take curd. You take the additional input from outside, lactobacilli, which is a friendly bacteria. That's how we manage. Vaccine doesn't kill the bacteria. Vaccine only increases your immunity power. That is a defense kind of a system. The drug is an offensive way, vaccine is a defensive way. Vaccine, when you add a vaccine, it first creates an antibody. And whatever pain or whatever fever that you experience while you are vaccinated, that is due to the side effect of formation of the antibody. The antibody formation takes place. It takes also for some time. It's not that from the 0 day of vaccination you are going to be resistant to that particular disease. No. For example, cholera has a 6 days incubation period. If you take a cholera vaccine, you have to, after 6 days, this vaccine is going to be, the antibody is going to be formed. The antibody acts as a lock and the bacteria for which this antibody is made, bacteria or fungus, they act as a key of the lock. Since every lock has a specific key, so every antibody is a specific to a particular antigen. First, antibody binds with the antigen, and this antigen-antibody complex is fairly stable. They are more stable than enzyme-substrate complex, and they follow Fisher's lock and key hypothesis. The antibody-antigen complex is fairly stable, means they do not attach by covalent bond, but they are fairly stable, means they do not fall apart at the physiological temperature. So that's why the antibody specificity towards a particular antigen is ensured by its complementary arrangement, by its lock and key arrangement. Next slide, please. Next slide. $1 billion question, can chemical agent eliminate virus? Simple answer is no. Up till now, no. It has not been discovered so far. Such a smaller molecule of nearly a molecular size, 20 nanometer to 200 nanometer. How can we expect that a chemical is going to attack that particular very small, tiny particle of molecular dimension? But vaccine, yes, vaccine can be developed. So there was in the earlier webinar, when I was hearing, I was on the other side in the gallery. I was hearing that somebody is telling that our foreign buyer is telling that they have a supply of antiviral agent that has to be sprayed on the footwear or the leathers before exporting, so that it is corona free. I got stuck up. So I used the term virocide in analogy to bactericide or the fungicide. The using virocide on leather surface, somebody said that using virocide in the leather surface could be our unique selling point. I don't think that it's going to be a unique selling point. If you do a shipment, the ship will take at least 1 or 2 months to reach to the destination. And virus has a lifetime of 14 days, even if it is contaminated. Now, it has no option to reproduce itself during the shipment time period because there is no host cell around. Leather is not a living host cell for that kind of a coronavirus. So it has to die a natural death, or it will be remain in the air, not in the leather. This is a risky too. Why it is risky? Because you are producing document or telling your buyer that my leather is corona free, COVID free. Now the buyer is not a retailer is not your buyer. It goes through several handling process. It goes finally to a retail shop. And suppose a consumer, a customer gets attacked by corona due to the handling, due to the exposure that has taken place by the overseas, in the overseas. The buyer will put a blame to you because you have said that it is corona free. They will put a blame to you and ask you for a compensation. And because there is no virucides exist, it will be difficult for us to defend in the international court of law. So instead of a USP, it could be a very negative point to consider at this point. Next slide, please. Next slide. Now, what is the post? Let's go one after another, right? What is the post-COVID prospect that I can see? I can see a silver line, a very positive approach. What is that? The over-dependency on China is going to be reduced. Whatever the death that has occurred in the European countries are the elderly people. Europe grew much faster. There are more number of gray people in the Europe. And China having the largest number of young people, and next is India. After all, you need some young people to push the lock, stock and barrel. It's not the old person they are going to do it. Retired pensioner will not do it. Therefore, India has an option, wide option for attracting the foreign direct investment, because I guess foreign direct investment in China in few years, in days to come, is going to be reduced. And there are many countries who are giving bail, who are granting funds for dislocating their unit from China to other countries. So we have an opportunity to attract the foreign direct investment in the post-COVID area, in the post-COVID period. As I said, next to China, India has the largest share of young people. So the demographic dividend can be in favor of India with the withdrawal from China. But in that case, my humble submission to all my leather fraternity, that forget about fragmentation in leather industry. Every organ of the leather industry should be amalgamated in a big melting pot, so that whenever we face the angel investor or we face the regulatory authority, we take care of all the organs. In a human body, if some organ doesn't function, the human body cannot exist with the full efficiency. If your head is not working, your hand will not work. If your leg is not working, you cannot work. It's the same thing that happens. There should not be a conflict of interest between us, and it is expected there should not be also a quid pro quo. We must speak in the same tongue, and we can quarrel amongst ourselves, but not in front of the angel investor or in front of the regulatory authority. The cluster concept, as rightly Jagannathan sir, NRJ sir has pointed, has to be revisited to explore the possibility whether we can produce mass production capability of China. And in that case, the Italian model could be an option and can be an option. So therefore, it needs to be studied that how we can do a better option, better productivity in redesigning the clusters. This not only increases the productivity, but also each unit is going to be very special or particular 1 or 2 unit operations. That is the dividend of this kind of division. But for that, you require an integrated plan. I can see also there is a huge scope for the first time possibly in India for development of indigenous leather machineries, whether for footwear, leather goods, or tanneries, etc. Maybe in terms of joint venture. And if there is a joint venture, as it was pointed out in earlier webinar also, then it should be on equity basis. Not only sharing or selling or purchasing the machinery at a cheaper rate and then washing your hands. No, not like that. Every aspect of the business, from procurement of raw material to marketing, has to be had on equity basis. Next. And what we need at this point of time, our think tank should put their heads in making an all forward-looking and all-inclusive plan has to be drawn out. Strategies has to be laid down and formulated. Action has to be initiated until we reach the roadmap. In the process of reaching the roadmap, in the process of traveling towards the roadmap, there must be an audit, what we could achieve, what we could not achieve, what are the plan that was achieved, what is the plan that could not be achieved during that time frame. That is, what is the milestone that we touched and what milestone we could not, so that we can make up that one. Next one. Next one is a question that what if the lockdown is partially withdrawn? Suppose the government decides and government tell us, suppose that from 4th May, we don't need to be locked down, the lockdown is withdrawn, but you can work, but with following a COVID norms. Then what we should do? What should be our first priority? Our first priority that we must prepare a tailor-made SOP to prevent community contamination of COVID-2. Standard operating procedure has to be made following the guidelines. Now, how will you make it? How can I make it? There are lots of central government, state government, corporate sector, big corporate sector, public sector unit has prepared their own SOP following COVID guidelines, and these are available in the net. We can download them. With this could be a raw material for our tailor making. We have to tailor make it depending on our position. And in tailor making, every minutest detail has to be looked into. That means from commutation, reaching to the gate, washing the hand, sanitary and others, then workplace, all these things has to be physical distance maintaining has to be taken into. And we have to plan also, how do we do the staggering or change of shift or maintain physical distance during the working time. And it has to be done in advance. It must be planned in advance. And that has to be trained to the people. Safety gadgets like mask, soaps, hand sanitizer, PPE, cleaning, and training the people and displaying do's and don'ts in various different places has to be maintained. Social distancing is a very important factor, not for killing COVID. It will not kill COVID, but it will break the chain of that particular exponential tree, that the chain that I have shown is going to be broken, and that will give a positive effect on the number of corona victims will be reduced, will be going down. Next slide, please. So there is no need to be panic stricken. There is no need to be panic stricken. There is a thumb rule in general. The contagious virus are more level, no doubt, but less lethal. Fortunately, the human cell are not the most preferred cell even for CoV2. And what we expected that mutation rate would be much higher, but it was found experimentally not so. The mutation rate, on the contrary, is lower than that has been estimated. So I am confident that if we work together with a forward-looking plan, all-inclusive plan, we shall overcome the crisis. Thank you so much. Namaskar.